These are your notes for Unit 9, Day 3 of PreCalculus. If you would like to see the warm-up, review question, or any homework questions we covered in class today, just look at the finished notes. So today we are going to talk about complex numbers and how to plot them in the complex plane or find the distance from a complex number to the origin. And we will be able to convert between complex numbers, rectangular numbers, polar numbers, and exponential numbers. So we'll be able to convert between the 4 different forms: complex form, rectangular, polar, and exponential. We will be able to find the product and quotients of complex numbers in their different forms. We'll be able to use something called DeMoivre's theorem, and we will be able to find the roots of complex numbers. So what is a complex number? So you might remember from Algebra 2 that complex numbers are numbers that have a real part and an imaginary part, where the A in most books is called the real part of your complex number, and the BI part is called the imaginary part of your complex number. So 3 minus 5i is a complex number where 3 is the real part and negative 5i is the imaginary part. And remember, I is your imaginary number, which is the square root of negative 1, and I squared is negative 1. I believe in this book, instead of doing a plus bi, I think they do x plus yi. So the x is the real part and the yi is the imaginary part, or you could do x minus yi. So how do we plot points on a complex plane? So notice in your complex plane, the x-axis is called the real axis, and the y-axis is called the imaginary axis. Notice because in our imaginary numbers, so if we have imaginary complex numbers, we have z is going to equal x plus yi. So in our example, we have z equals the square root of 3 minus 1i. So in that example, my x-coordinate is the square root of 3, and my y-coordinate is going to be negative 1, because we have z equals the square root of 3, so that's my x-coordinate, minus 1i, so the y is going to be negative 1. So we are going to plot the point negative 3, 1 if we are on the real plane. But to plot the point, the square root of 3 minus 1i, we're going to move the square root of 3 over, and the square root of 3 I think is about 1.78. So we're going to move 1.78 over and then negative I up, and so, or sorry, negative I down. So negative I and then 1.78. And so that would be the point, the square root of 3 minus I. So that's where that point would be on the complex plane. And so we could connect it to the origin, just like we rotate for polar form. And so that would be the point, the square root of 3 minus I. If you want to find the magnitude or the distance between that point and the origin, you use the magnitude of z. That's not the absolute value. It's kind of like a vector. It's going to be the magnitude. It's going to be the square root. You take the real part squared plus the imaginary part squared, or the coefficient of the imaginary part. So in our example, we're going to take the square root of the square root of 3 squared plus negative 1 squared. And so this is going to be 3 plus 1, or the square root of 4, which is 2. So the length of that little segment is going to be 2. Or the magnitude of z is going to be 2, because that is its distance from the origin. And we can call that the modulus, or the magnitude of z, or the complex number, square root of 3 minus 1i. All right, so how do we take a complex number and convert it to polar form? Well, if you take a complex number, so z equals x plus yi, in polar form, we're going to write this as r, so the radius times the cosine theta plus I sine theta. Or if you distribute that out, it's r cosine theta plus I times r sine theta. And notice, if you remember from our previous sections, r cosine theta is equal to x, and r sine theta is equal to y. So that makes sense that to take a complex number and change it into polar form, you would have r cosine theta, which corresponds to the x, and then you have r sine theta, and r sine theta corresponds to the y. So it makes sense that to convert from complex form to polar form, you use r cosine theta plus I r sine theta, or you can factor out the r. Well, if we solve for cosine theta and sine theta, remember this is what we were doing way back in Unit 6. So when we drew in that triangle in the first quadrant, we have theta, and that could be the point xy. So we went out x and up y, and that's r. And so the cosine of theta would be adjacent over hypotenuse, which was x over r. And sine theta is opposite over hypotenuse, which was y over r. And that's where those formulas are coming from. And so the formulas that we can use to change from complex form to polar form would be in that box. So cosine theta equals x over r, sine theta equals y over r, and those two allow us to find theta. So we use those to find theta. And then to find r is going to be the magnitude of z, or it's going to be the square root of x squared plus y squared. So if we have z is equal to the square root of 3 minus 1i, let's find r first. So we know that x is going to equal the square root of 3, and y is going to be negative 1, just from this is x plus yi. And so we're going to do r squared equals x squared plus y squared. And so r squared is going to equal x squared is the square root of 3 squared plus y squared is negative 1 squared. So r squared is going to equal 4. So r is going to equal 2. So now I know that r, or the radius in polar form, is going to be 2, or it's the modulus or magnitude of z. So r is also the magnitude of z, which is the square root of x squared plus y squared. So now we have r. Now we need to find the angle. Well, we know that the cosine of theta is equal to x over r. And the sine of theta is going to equal y over r. Well, x over r, we know x was the square root of 3, and now we know r is 2. So the cosine of theta is going to equal the square root of 3 over 2. And the sine of theta is going to equal y over r. Well, y was negative 1, and r is 2, so that's going to be negative 1/2. So now we're back in our tables from Unit 6. When is cosine positive and sine negative? Well, all students take calculus. Cosine is positive and sine is negative down in the fourth quadrant. So I know I need to be in the fourth quadrant, and I need cosine to be square root 3 over 2, and I need sine to be 1/2. So I need to be at a pi over 6 in the fourth quadrant. Well, the pi over 6 that's in the fourth quadrant is 11 pi over 6. So that means that my theta is going to be 11 pi over 6. So now I have theta is 11 pi over 6, and I have r is 2. So to convert z, which is the square root of 3 minus I, into polar form, well, it's going to be r cosine theta plus I sine theta. That's our formula. So it's going to be 2 was the radius, and then the cosine of 11 pi over 2. So that'd be a cosine 11 pi over, not over 2, over 6, plus I, the sine of 11 pi over 6. And that would be our complex number in polar form. So again, we found the radius using r squared equals x squared plus y squared. And then we found our theta using cosine theta is x over r and sine theta is y over r. And then we just use the formula. X plus yi is going to equal r cosine theta plus I sine theta. And then we just substituted in r and theta. All right. We also have a new form called exponential form. So if we have an imaginary number, or a complex number, z equals x plus yi, remember in polar form, this is r times cosine theta plus I sine theta. And this in exponential form would be r times e raised to the I theta. So if we want to convert from exponential form, from polar complex form into exponential form, first we need to convert it into polar form. So remember, we're going to use r squared equals x squared plus y squared. And so in our example, x is square root of 3 and y is negative 1. So r squared is going to equal the square root of 3 squared plus negative 1 squared. And so r squared is going to equal 4. R is 2, just like what we found from before. And then again, if we wanted to find theta, well, we know cosine theta is x over r, and sine theta is y over r. So just like we did in our previous slide, x over r would be square root 3 over 2. Y over r would be negative 1/2. And we found theta. This would have to be in the fourth quadrant, and it's a pi over 6, so it'll be 11 pi over 6. So in polar form, we have z equals the square root of 3 minus I. That's complex form. In polar form, it would be 2, and then the cosine of 11 pi over 6, and then plus I, the sine of 11 pi over 6. And if we want to put this, so this is complex, this is polar, oops. And then if we want to put it into exponential form, we use the exponential formula, r, so the radius times I, and then times theta. Well, theta was 11 pi over 6. And so we have 2e raised to the I times 11 pi over 6, and that would be that complex number in exponential form. All right, so let's plot the corresponding point. Z equals 2, parentheses, cosine pi over 6 plus I sine pi over 6, which is 2ei times pi over 6. So we have polar form, we have exponential form. So let's convert this into complex form. So we have complex form would be x plus yi, and right now we're in polar form, which is 2 times cosine pi over 6 plus I sine pi over 6. And so the cosine at pi over 6, which would be square root 3 over 2, and then plus I, the sine at pi over 6 is 1/2. And then if I distribute it in that 2, I would get the square root of 3 plus I. And so that point in polar or exponential form, in complex form, would be the square root of 3 plus 1i. And so the square root of 3 plus 1i, well, remember the square root of 3 was 1.78, and then I. So in complex form, we would be right there, square root of 3 plus 1i. So that's where I would be. Or it's the point where we would have a radius of 2, or that modulus is 2, and we've rotated up pi over 6 degrees, or 30 degrees. All right, how do we find products and quotients of complex numbers? Well, the good news is you are just going to multiply the radiuses, and then you are going to add the angles. Because if we think about it in exponential form, we have radius 1, we have radius 2, and then we have exponential form, we have theta 1 and theta 2. And remember, if you take r1 ei theta 1 times r2 ei theta 2, you can multiply the r1 and the r2 because those are coefficients. And then remember the rules for exponents is you can add the exponents as long as they have the same base, and we're multiplying. So this would be I theta 1 plus I theta 2. So you would add the exponents. So when you are multiplying two complex numbers, you multiply their radiuses and you add the angles. So multiply the r's and you add the thetas. If you are dividing two complex numbers, you divide the radii. So we would divide, and then remember when you have two bases and they two terms and they have the same base and you're dividing, you subtract the exponents. So it would be r1 over r2, and then it would be ei theta 1 minus I theta 2. So you would subtract the exponents by the rules of exponents. All right, so let's look at an example. So let's say we have z is equal to 3 cosine pi over 9 plus I sine pi over 9. So that's in polar form. And w would be 5 cosine 5 pi over 9 plus I sine pi over 9. So for a, we want z times w, which would be, remember, you multiply the two radiuses, so 3 times 5, and then we would add the angles. So it'd be cosine pi over 9 plus 5 pi over 9, and then plus I sine pi over 9 plus 5 pi over 9, and that would be it in polar form. So let's simplify this. So this would be 15 times the cosine of 6 pi over 9 plus I sine 6 pi over 9. And if I simplify that, that would be 15, and then it would be the cosine of 2 pi over 3 plus I sine 2 pi over 3. That would be in polar form. And then an exponential form, remember you do r. So in this case, it would be 15, and then EI, and then times the angle, which was 2 pi over 3. So we've got polar form, and we've got exponential form of z times w. If we wanted to do z over w, well, we would take z divided by w. So I would have 3 over 5 for my radii, and then it would be the cosine. Then you subtract the angle, so pi over 9 minus 5 pi over 9. And then plus I sine pi over 9 minus 5 pi over 9. And if I simplify this, I would get 3/5, and then it would be the cosine of negative 4 pi over 9 plus I sine negative 4 pi over 9. That would be the quotient in polar form. And then in exponential form, it would be the radius, and then EI, and then times the angle, so negative 4 pi over 9. So those would be your products and quotients in polar form and exponential form. All right, DeMoivre's theorem. So what if I'm going to take an expression in polar form and I want to raise it to a given power? So I want 2 cosine pi over 9, I sine pi over 9, and I want to raise it to the 3rd power or the 7th power or the 8th power. Well, notice, what's the rule? You multiply the radii and you add the exponents. Well, in this case, multiply the radii, add the angles. So I'm going to basically distribute that 3 in as an exponent. So I'm going to do pi over 9 3 times, or 2 times pi over 9. So in polar form, this is going to be 2 to the 3rd, and then it'll be the cosine of 3 times pi over 9, because I want 3 of them, right? Because it would be cosine pi over 9. So if in exponential form, this would be 2EI to the pi over 9. And I'm going to do that 3 times. So the 3 goes here and the 3 goes here. So it would be 2 to the 3rd and then EI to the 3 pi over 9. And that's why we're going to do, and then plus I sine, and then the 3 is also going to go to that pi. And so this is going to become 8, and then it will be the cosine of 3 pi over 9 plus I times the sine of 3 pi over 9. And so we would get 8 cosine pi over 3 plus I sine pi over 3 after we reduce. And that would be my expression in polar form. In exponential form, this would be 8EI to the pi over 3. And then in rectangular form, we're going to evaluate this. So this would be 8 times the cosine at pi over 3 is a half. And then plus I, the sine at pi over 3 is square root 3 over 2. And then distribute in that 8. And we would get 4 plus 4I radical 3, or 4 radical 3I. So we've got rectangular form, we've got exponential form, and we've got polar form. So polar, exponential, and rectangular form, or complex form. All right, so why don't you guys pause the video and try and express 1 plus I to the 5th in exponential form and in rectangular form. All right, so we are currently in complex form. So we have 1 plus I, and we want it to the 5th. Well, that means that x is 1 and y is 1, because this is z equals x plus yi. So let's find our radius. So remember, the r squared equals x squared plus y squared. And so r squared is going to equal 1 squared plus 1 squared. So r squared is going to equal 2, or r is going to be the square root of 2. So that's going to be my radius. And so now we're going to have 2, and then we've got something to the 5th power. So we're going to put it in polar form or exponential form and then deal with the 5. And now we've got to find theta. Remember, cosine theta equals x over r, and sine theta equals y over r. So x over r is going to be 1 over root 2, or if you rationalize, root 2 over 2. And y over r is going to be 1 over root 2, which is root 2 over 2. So both cosine and sine are positive, so I'm in the first quadrant. And for sine and cosine both to be root 2 over 2, theta needs to be pi over 4. So my theta is pi over 4, so it's going to be cosine pi over 4 plus I sine pi over 4. And then that's all going to be to the fifth power, or in exponential form, it would be 2ei to the pi over 4, and then raised to the fifth power. So we could distribute in that 5, 2 to the fifth, and then ei to the 5 pi over 4. And 2 to the fifth is 32, so I have 32ei times 5 pi over 4. So that is in exponential form. And then if we put it back into polar form, remember you would add the angles. So this would be 32, and then we would have cosine 5 pi over 4 plus I sine 5 pi over 4. And the cosine at 5 pi over 4, well, at 5 pi over 4, I am in the third quadrant, so this would be 32. And then the cosine at 5 pi over 4 is negative root 2 over 2 plus I. The sine at 5 pi over 4 is negative root 2 over 2. And then distribute in the 32, and we would get negative 16 root 2 plus, well, we could do minus because it's a negative, so minus I, and then it would be 16 root 2. And so this would be in exponential form, this would be in complex or rectangular form, and this would be in polar form. So polar, complex, or rectangular form, and then this would be exponential form. So that is DeMoivre's theorem. Finding complex roots. So what if we want to find the complex roots of -1 plus the square root of 3 times I and express it in exponential form? All right, well, this guy in exponential form, so it would be, we've got to find our r, and so x is -1, y is square root 3, because remember z equals x plus yi, and we have z equals -1 plus the square root of 3i. So this is going to be r squared equals x squared plus y squared. So r squared is going to equal -1 squared plus the square root of 3 squared. So r squared is going to equal 4, so r is 2. And then remember, cosine theta equals x over r. Sine theta equals y over r. And so x over r would be -1/2, and y over r would be the square root of 3 over 2. And so for cosine to be negative and sine to be positive, I'm in the second quadrant. And I would be at a pi over 3 in the second quadrant for cosine to be 1/2 and sine to be square root 3 over 2, and that would be 2 pi over 3. So z equals -1 plus the square root of 3i in polar form would be 2, and then it would be the cosine of 2 pi over 3 plus I sine 2 pi over 3. And in exponential form, we would have 2ei times 2 pi over 3. And so if we want to find the complex cube roots, we're going to use this formula. So the cube root, so it's going to be the nth root. So in this case, it'll be the cube root of the radius. So my cube roots would be the cube root of 2. And then we've got ei, so ei, and then it's going to be 1 over n. And in this case, it's cube root, so it'll be 1 over 3 because we're doing cube roots. And then it'll be times theta, which is 2 pi over 3, and plus 2k pi, where k are integers. And that's how we would find the nth, or all of the cube roots of that expression in complex. So those would be the complex cube roots of -1 plus square root of 3. And so zk. So if k equals 0, I think we start with 0. Yep, so where k is 0. So if k is equal to 0, so that would be z sub 0, we would get the cube root of 2, and then ei 1 over 3 times 2 pi over 3 plus 2 times 0 times pi. And so we would get the cube root of 2 times e to I raised to the 2 pi over 9. Or we could do, what if k is 1? So same thing. So we could find all of the roots going from k equals 0 all the way on up. And that is how we would find complex roots of an expression in complex form. We could convert it into polar form or exponential form and then use that formula to find the complex roots. Your homework is from 9.3. Let me know if you have any questions.